Hi, my name is Sandro and this is Codurance's screencast. As some of you may know, I was recently involved in some discussions on Twitter where I was saying that TDD does not lead to a good design if you don't know what a good design looks like. After a long debate, I decided to record a video to show how I normally code. Differently from previous screencasts, this video is not for beginners in TDD. It assumes that you understand how mocks work and also that you have a reasonably good understanding of software design. The way I code in this video is the way I normally code, but not the way I normally teach. Some of you will notice that I skip the traditional refactoring steps a few times, and I do quite a lot of design up front, or just-in-time design as I prefer to call it, without much feedback from my code. This is normally the case for many experienced TDD practitioners who use Outside-In TDD. If you are starting with TDD, don't follow the advice in this video blindly. You should probably use the classicist approach, design less upfront, and rely more on the feedback from your code in order to evolve your design. In order to demonstrate how I normally code, I chose the bank kata. So my task is to create a bank application where I have an account class, which I can deposit some money, withdraw some money, and call the print statement. So I can print my bank statement to the console. The acceptance criteria for that is after depositing and withdrawing a few times, I should print my statement. The statement should have three columns: the date of the transaction, the amount of the transaction, and the running balance. And the transactions should be displayed in my statement in reverse chronological order, like you see in your normal bank statement online. To make things a little bit more interesting, I have a few constraints and I have a starting point. So my starting point is an account class. The account class has three methods: the deposit that receives an amount, withdraw that also receives an amount, and a print statement. Note that all the three methods are commands. They don't return anything. Um, Also, I cannot add any other method to this class, any other public method to this class, and I cannot change the signature, which means that I cannot have a query method. So when I'm testing this class, I need to call the command methods, but I need to test behavior. I cannot query the state of the account and test for it. Also, in order to keep this exercise simple and short, I'll be using strings as dates and ints or integers as amounts. So I don't need to deal with date formatting and big decimal and anything like that. And I don't need to worry too much about the formatting of the thing that is being printed to the console. So here I have my README file and has the description of the problem. And so this is what I need to achieve. I will start with an acceptance test first. So I will create a package called feature. And inside this feature, I will call print statement feature. So the print statement feature, I will have a acceptance test in here. I will call print statement containing all transactions. So, because if I look at here, so a statement should have transactions in the following format. So here, according to the domain language, it's saying that my statement is a kind of a collection of transactions in a way, or a list of transactions. I know that they are in reverse chronological order as well. So here's the thing. Containing. So here's the thing. In order to write an acceptance test, we need to identify the side effect. So what are we testing? So what these acceptance tests is going to be testing. So in this case, what we want to do is to print this all the transactions, the statement to the console. So that's what we should be testing for. So I'll treat the console as if it was an external system, the same way that I would treat the database. So normally if I have an external system, I would have an interface to isolate my application from the external world. So let's copy this. Let's use the same example. So let's paste it in here. Let's say, so what we could do and say, we verify that the console print line. So what we could do, so we just verify if all these lines are being printed to the console. Yep. So let's make our lives easier and remove some of this space. So this will be my test. So at this point, I already decided that console will be some sort of an interface, or will be a class that will represent the console. And whatever I do, my acceptance test will need to verify that the method printLine in the console class was called a few times with all the information that I need. So let's make it compile. Let's create a field. Let's call it console. Java has a console class, but I don't want to use the Java class. I want to use my own console. I want to have full control of my interface. So I will create, let's create a package here. Codurance.kata. For now, I'm gonna put everything in the same package. So split my screen. So, okay. And I need to, let's get this verify here. That's the Mockito verify. And this guy will need to be a mock. I'm using Mockito. What's it? Mockito, JUnit runner. And so I will want these methods in here to be called, and this will be a text. So I'll leave like that for now. Okay. Now that I know what the side effect is, I need to identify the trigger to the side effect. So if I say, let's count.print statement. So when I call the print statement in the count class, then this should happen, right? And in order to have all these things, I need to have a deposit of 1,000, then withdraw of 100, and another deposit of 500. See that is in reverse chronological order. So my first deposit is here, and the second deposit is in here. The withdrawal happens after the first deposit, and this is the last deposit. So basically what I would have is something like account.deposit of 1,000, and then account.withdraw of 100. So here I cannot withdraw minus 100. That doesn't make sense. So this should always be positive. I deposit 100 pounds, I withdraw 100 pounds. I don't withdraw minus 100. So paying attention at this type of semantics is very important in the code. So deposit of a 500. Right. So, okay, that would be my test. Of course, I need to create this. This will be, I'll call it account. Let's create a class account. This one I will create on Codurance and kata. So that's my account. I'm gonna move there, and so let's create these things. This is the amount. This is the withdraw. That's amount, and then the print statement. Right. Those are the three methods defined by my specification that I cannot change. So my account class needs to have that. So I believe that now I'm ready to finally run my my acceptance test. Oh yeah, this is gonna throw an open-pointed exception, of course, and I will initialize this here. Account, new account. So if I run it again, okay, unsupported operation exception. I normally keep, when I create, so I normally write everything on my test the way I want to read, and then I start creating my code from my test. I configured my IDE to always throw an unsupported operation exception, because then every time that I run my tests, I always know what's not implemented or what is left to be implemented. In this case, is everything, of course. Before I move on, I would like to see my acceptance test failing for the right reason. So now it's failing because there is an unsupported operation exception. So I will remove that and then run it again. So there is another one in the withdraw and another one in here. So if I run that now, okay, so what is the testing say? Okay, so the test is saying that wanted but not invoked. So the test was saying that it was expecting the console mock to be called, but it was never invoked. So now what it means is that my acceptance test is failing for the right reasons, right? So there's no exceptions, and then when it comes to verify my side effect, this is not happening. That's exactly what I was expecting. So now I need to decide what to do. Before I move forward, this test is still not quite there yet, because the order that these things happen is important. So what I will do, I'll say in order, in order console, and I'll make sure that the mock, the console mock, the method print line in the console mock is invoked in the right order. So in order, and this. Okay, so now it's better. Now I'm happier. Cool. Still failing for the same reason. The next step for me would be, so as my acceptance test is failing for the right reason, it's time to park the acceptance test. And now this is the double loop of TDD. So first we start with an acceptance test. Once the acceptance test is failing for the right reason, then you go to the inner loop of TDD, that is the unit test. So now I'm going to start unit testing my code, and then hopefully once I finish unit testing all the classes that I made, that I may have, then this acceptance test should go green. One thing that just came to my mind was like, if this is a mock, and that's what I'm verifying, clearly I'm not injecting this mock anywhere, so I should inject my console into my account. However, I'm not quite sure if the account will be the one calling the console. I'm not quite sure how many abstractions I will have. For example, from the account being the first class to be invoked, I don't know what I will have between the account and the console. I don't know if I'll have more classes, and that's the reason that I'm not gonna change this test right now. I'm not gonna inject this console. I'm gonna go down to the unit level, start unit testing the account, and then I will see if the console must be invoked must be injected into the account or somewhere else. So let's start with a unit test now. Let's create the tests. I'd like to call my tests account should, and I'd like to have my tests on the left. So what should the account do? What should the account do? So I would like to start with the simplest test that I can possibly find. So the deposit looks like a good candidate. The interesting thing about this exercise is all the methods in the account class are commands. And according to the initial constraints, I cannot change this interface, which means that I cannot change the signature of the three methods, and I cannot add any other public method, which means that there's no way that for example, a common approach that's very common in the classicist approach would be we invoke deposit, and then we have a query method that would say call deposit of 100, and then call a method, let's say get balance, and see if it returns 100, and that would be your test. There are many problems with this approach. First, you are exposing a query method like getBalance that just for the purpose of testing. Another thing, why do you need a getBalance at all, right? If I look at my my requirements in here, there's nowhere, I cannot find any place in here where I need a total balance. What I have in my statement is a running balance that is very different from total balance. So after each transaction in my bank statement, I have a running balance. So keeping the total balance, it's not necessary for my need or to implement this feature. Another thing, if I do this, for example, if I call deposit of 100, expose a method, say get balance to return 100, which means that I will satisfy my test. My test will go green, but my implementation will do what? Will store that deposit in memory inside the same account class. So when we are writing tests, we need to be realistic, right? So one thing is to make the test goes green. Another thing is to make the code being useful, because there's no point in me providing a get balance somewhere in my account class. So let's say I call deposit, pass 100, store that in a variable, store my amount in a variable, and then my get balance return that variable. Right? I won't store my deposit in memory. If I bounce my application, I lose all my data. That doesn't make sense. So I need to focus in what is the side effect of a deposit. What do I want to happen when a deposit is made? Another thing is, I don't want to test my deposit through my print statement, because if I test my deposit at a unit level through my print statement, my unit test will be exactly the same as this one, where I call deposit, withdraw deposit, then I call print statement, and I check the side effect. So this is an acceptance test. my unit test is not the same thing. So we need to think about these operations as separate operations. So imagine like me as a client from a bank. I go to the bank and say I want to deposit 100, and then I go home. I don't want to print my statement. I don't want to do anything else. I just want to deposit 100. Next day, I go to an ATM machine and I say I want to withdraw £50. I don't want to check statement. I just want to withdraw my £50. And then at some point, 1 week later, I want to print my statement. The only thing that I care is that all my transactions were logged, that my deposit must be there, right? So when I deposit something, the side effect that I expect is that that deposit transaction is stored. That's the side effect. And if I, and here say a statement should have transactions. So transaction is a domain term. So basically what I'm expecting is to store deposit transactions. So that's what I should be testing for. Now that I identified the side effect I want, that is I need to store a deposit transaction as a side effect for the deposit invocation, I need to do something that is not so common to many seasoned TDD practitioner. They would just start typing on the keyboard and of course they would try to get a query method there somehow. But Outside-In TDD is slightly different. We do design while we write the tests. So all this conversation, all these things that I'm considering at the moment, what is the side effect, what I'm trying to, this is all design. This is all design because now I need to figure out, so if I call deposit with 100, I need to store a transaction. What? How does it, so what is a transaction? So if I go back to my requirement, I have an amount. The only thing that I have in the signature of my method is an amount. One thing that I know is I need to bind whatever amount I pass here to a date. And I assume that this is the current date. So as soon as I make a deposit, so if I make a deposit today, I need to create a transaction that that has this date, that is today's date. My statement tells me that I should have the running balance, but then that's another question, like, should I store the running balance within a transaction as well? See, those are all design decisions that we need to make. And each design decision, like design is all about trade-offs, right? So, for example, if I create a transaction object that has the current date, the amount that I passed in, and the running balance, so I will need the account controlling the running balance and figuring out what date it is. The problem when you is that I'm creating a transaction object, thinking about how it's going to be printed. But is this the right thing to do? Right? What if I print in a different way? What if I don't need the running balance anymore? What if I receive transactions? So imagine that I have a list of transactions, and then after each deposit and withdraw, I keep calculating the running balance according to the last transaction. But let's say that I may receive transactions in batch. Like let's say that I went abroad and transactions that I made a few days ago will just enter into the system today. So what do I do with all the list of transactions? Do I recalculate? Do I recalculate all the running balance because I received transactions today that were related to 1 week ago? So all of these things is not that we are trying to foresee the future, but we need to at least ask some basic questions. And these basic questions may lead us to, may give us some directions, let's say. So in this case, if running balance is something that I can calculate on the fly, this is already a hint to me that everything that can be calculated on the fly, I would never store in an object. I will only do that if at some point I have some performance issues, and then I need to keep that already calculated so I can easily print my statement. But if I don't need to do that, I probably won't store it. I will calculate on the fly. So my transaction, I would probably just keep date and amount. It's it seems that there's a lot of work in the deposit method. So if I call deposit, I need to somehow get the current date. I need to create transactions. I need to store it. I need to do quite a lot of stuff in there. I'm wondering if I can defer some of these things. What if I just focus on delegating that and just say, just store a deposit to me? I think that what I'm trying to say is something like that. What if I express my test in a much simpler way and say an account should store a deposit transaction? And of course that the account itself should not know how transactions are stored. So someone else needs to do that. Normally, we use the repository pattern. So we could say we verify that the transaction repository say add deposit of 100. So when I want to store a transaction through the account, I verify if the deposit was added to the transaction repository. That is looks simple to me. Let's create this field. Let's say transaction repository, and let's create this class, and let's move that to the other side, make it bigger, and let's create this method. Right, so, and then what I would do is say account dot deposit 100. So if I deposit 100 into my account, I expect that I will add a deposit of 100 to my transaction repository. This way, it's quite simple. I will defer the logic of creating transaction, figuring out the date in the account. I will just defer. I will push the details of this operation a little bit further down into my system. So let's create this as a field, new account, and in this case this will be a mock, and I will need a run with runner.class, and if I run this test, so what is it saying? Yeah, so my mock was never invoked. Of course I normally prefer to do this. Oops. Right, and I will need to inject the transaction repository into the account, and let's make it a little bit smaller. And of course, if I run my tests, okay, interesting, because now my statement, my acceptance test is failing, of course. So what I will do, I will say transaction repository, and let's create a local variable, new. Of course, in my acceptance test, I will use the real repository. In my unit test, I'll mock it, because my acceptance test is testing the system as a whole. I'm just mocking the external world. I'll keep the repository. I'll have an in-memory repository for this exercise, but normally I mock the external world. So here, let's run it again. I should get an unsupported operation exception. Yeah, cool. So let's fix that, and let's assign that to a field. Let's make it a little bit smaller. And okay, let's look at it. Right, it was not invoked. Then I can say, okay, and if I run, cool, that sounds great. Now I would like to test the withdraw. So should store a withdrawal transaction, and that would be similar to this one. And so I will say withdraw 100, add withdraw of 100. Okay, and so if I run that, yeah, never called, easy. I'll withdraw amount, run it. Okay, so now deposit and withdrawal, I defer the decision to further down to my repository. Now I need to start thinking about my print statement.